Hello again. I'm back after a couple of weeks off to move house, as you can tell by my new background and slightly messy background because I'm still unpacking. But I'm back and ready to start doing some Haskell again, which is cool. Been a couple of weeks, so I've kind of forgotten where I've gotten up to, so it might be a little bit slow today. And I haven't written any Haskell for a couple of weeks, so I might have forgotten how it works. But hopefully I can get back into it. And I'm going to start with a little bit of tidy up from last time, just mostly to remind myself what I was doing. And then I want to look at the mock storage that I created for writing tests. So in the old abstraction I was using for storage, I could swap out the file storage for some test in-memory storage. And that's obviously broken now because I've changed the abstraction for storage. So I'm going to go back and fix that and update the storage abstraction to work with the new type classes I created. And then hopefully the test will start to pass again, or at least the tests will pass for the bits of code I've migrated. That's the plan. Okay, so let's get to it. There we go, some code. Oh, I've changed my font as well, just because everything has to be new. But right, okay. So, couple of things. One thing I remember from last time is that I'm building up this list of type classes of different kinds of storage, or the different abstractions that we need for storing different things. So the topic storage, for example, has got functions for adding, listing, and removing topics, and cast storage has got something similar for hosts and participants. And this list of constraints is going to keep growing. So when I add episodes, it'll grow again. And if I added more types of storage, it would keep growing. One of the questions I was thinking about last time was, can you somehow combine these constraints into like a super constraint? I actually looked this up just before this episode started, and you can. There's a way to do it. I don't know if it's going to make it better. I kind of like that this is explicit. It tells you all the different types of storage, but apparently you can just create a type alias for this. You need an extension. It'll prompt me in a second, but I can just write type alias and say storage s is equal to, and then just put the constraints inside here. So cast storage s and topic storage s. Okay, and now it's complaining because it wants constraint kinds, but I can add that as a language extension, and now that goes away. And hopefully, I haven't tested this yet, but in theory, you could write storage s at this point, and it'll be the same thing. Kind of makes sense because generally type aliases just get expanded. So I guess this just gets expanded, which would be the same thing. I don't know if I like that more. The explicitness of saying it can store casts and topics was kind of nice, but maybe this is quite nice as well. I don't know. I'll leave it in place and see how we get on with it. But I was just kind of interested in as to whether or not you could do it, and this seems to be a good way of doing it. Okay, the other thing, before I move on to the tests, is I've commented out the make file storage and replace it with make Postgres. And if I wanted to test the files, I would uncomment and recomment lines. What I'm thinking of doing is replacing this get args with something like get args and storage. I'm getting this to return a tuple back to me. So we'll get the args and the storage back from here, and then use that storage. I'm just thinking like I'll look at the first command line argument, and if it is maybe, I don't know, DB, then I'll use Postgres. If it's file, then I'll use file storage. I should really be using something like parse applicative and parsing command line options properly, but I can't be bothered doing that yet. So at some point, I'd like to come back and do that. But for now, let's not do it. Okay. So it's going to run under IO, obviously, because we're going to get the arguments out. It's going to return list of strings. I'm just going to move this definition up a bit. And it's not going to turn into B0. We're going to say, given some storage, return that S. So whatever it returns has to be some kind of storage. And then I can just comment that line out. Oh, it's maybe not super happy about this. Let's see if that error goes away when I actually implement this, but there's a chance this might actually not work. Okay, so my thinking for this is we will say case, we'll get the args first. So let's just get args. And then we can say case args of, and I just match on this. So if we have, yes, that. So we have db followed by some args, like the rest of the args. Then we will just say pure, and then the tuple containing args and Postgres storage, which is this thing. So let me just put some do for a second, and I'll drop that in place. And so we get the storage back and we return it, like so. If it is file followed by the rest, then I'm going to make file storage. Just show that in scope. So make file storage. Oops. Do you know what? I can combine those things. Otherwise, assume it's the args. And we'll default to Postgres. I got all these arguments wrong. Okay. So make up env. That's interesting, that only takes cast storage. Let me go through these one by one. So make file storage is not in scope because of this. That's one thing gone. Right. And now file storage doesn't work because this only expects cast storage. And I've told it it's of type storage. Let's pull that in. Okay, that doesn't work. So S is a rigid type variable bound by the type signature for get args storage. But what is expecting? So it can't replace, it can't unify S with PostgreSQL storage. So that's interesting. I don't know what it's to do with, it's probably not, but I wonder what it's to do with this typing that I used. That didn't make any difference. So just put it back to storage, which is what I really wanted. So I think this is because don't know why actually. Like it feels like I should be able to return storage because storage does implement, sorry, whether it comes back from here, postgresql storage does implement storage. If I tell it, if I change the signature here, so I say this is cast storage S and topic storage S. No, that doesn't work, so I'm just pushing error somewhere else. Okay. I've seen this before and I can't remember how I solved it. It seems that in general, this idea of returning something and constraining it to a type class doesn't really work. It should work though. Okay. I will, in that case, I'll come back to this some other time because I don't want to spend too much time on it tonight. I just want to do it quickly. So I'll do that instead. If I do it here, does it work it out? So I could say case args of, and I can, in particular, I guess I could say storage is equal to that. So case args of, in fact, I could do, I just inline the whole function, right? So I can say storage and the rest of the arguments. So if args begins with db, oops, I'm going to rename to all args. I'm going to call that args. I'm going to call this rest. And I'm going to say let, because that's how Haskell works. And then this will be all args. So if the arguments start with db and then have some other things in it, then we are going to return this thing, except it won't be pure anymore because I'm not running it under IO. Oh, there's something stupid about the indentation of this. Oh, change that, and then that one. So we have to indent beyond the equals for multi-line lets, I think. Ah, this also runs under IO. So because making PostgreSQL storage runs under IO, the whole thing needs to run under IO, and then it would become pure again. Okay, my indentation's all out now, but I'll let the formatter fix it in a second. If it starts with file, then we're going to make file storage. Okay, and if it starts with anything else, I'll default to Postgres. Okay. Okay, so what's going on here? So this storage, okay, so now storage has become a concrete type, and it can't be both PostgreSQL storage and file storage. And I don't think I can say it's a type storage. So that doesn't work either. Okay. So let me just turn it away. Okay, I'll abandon it. I'll come back to it at some point in the future because I do want to be able to switch between them depending on some command line argument, but I don't know how to do it. I don't know how to have something which returns an instance of a constraint. Okay, so I'll leave this for now. Just going to build it, make sure everything's still okay, but then I'm going to run the tests, which I imagine will not be okay. Ooh, where did I leave that? I didn't save the file, that's what happened. Okay, so it builds okay. Then we say compile test. I imagine when it's compiled everything, which might take a little while, I imagine it won't compile because the old storage, the old storage, the mock storage, is not going to work. It doesn't implement cast storage, basically, that's what it's complaining about here. And that's in host spec, so let's go there. Maybe host spec. Okay. What instance 6 is about? Don't know what it's from. Okay. Anyway, so mock storage. And it's implementing s.storage, and that's not what I want to implement. I want to implement cast storage and the other storage. Topic storage, I think it was. Okay, so we should be able to import this. And now everything is wrong. So the only thing this is currently implementing is loading hosts. Can I get it to fill it in for me? There is a way. Yes, this one. Does that work? It does not work. It still does not work. That's annoying. I wonder if it's because there's errors in here. The other thing we need to do is topic storage. It's a bit annoying actually because we're not using topics. Come on, you can do this. It cannot do it. Okay, what have we got in here? All of these things so we're going to take this X is going to become some instance of mock storage, and then we need to implement all the things, so implement all the constructors we need, and we'll implement this. So we'll import it, and then we'll need to import participant even though we're not using it, annoyingly. So add host, given some storage, we don't actually care what storage is, and some host, And I don't know how I did this before, but it's just going to be pure of right of unit. So we won't do anything. It's going to be the same for removing hosts, adding participants, and removing participants. Removing host should be okay. What's its problem here? Conflicting definitions. Is that because I imported these? Was that for a different reason? Nope. Okay. So where's the conflict? Oh, sorry, it's just because I haven't renamed them all yet. That was it. So this is adds, but it's participant this time. And remove. Okay, slightly better. Right, listing hosts. We don't actually use the storage for anything. And all we're going to do here is we want to return mock load hosts. And there should be a list of posts. So we can just map host over these strings. Okay, and then fix that to list hosts. And list participants we don't need to do anything with. So this is going to be, we'll just say pure of an empty list. Okay, this is not an either type. I probably made that more complicated than it should have been. But essentially, let me pull this to the top. So that's what we care about. And then, oops, we don't use these in this test. Okay, next one. So list hosts, no, it's not list hosts, it's list topics, I think. Let me go and copy them. And these are just going to be empty definitions because we don't use any of them. So again, the X here is going to be the concrete mock storage. We're going to need to import topic even though we don't use it. Okay, so adds topic, given some storage, and the name of the topic is going to be pure of right of unit. And list topics. We ignore the storage, and this is just pure of an empty list. And remove topic, ignoring the topic and the storage, and this is going to be pure unit. And this, let's do that. And what's complaining about now? So these can go. Okay, so now we have our mock storage, and then load hosts is now load host prime or something. I can't remember what this was called. No. If I go back to main, in fact, if I go to commands in hosts, so there's be commands in cast, we want to run this. Is that is not exported? So go back to the test. It's trying to run something inside the old storage, which I can't do anymore. But maybe I can just run hosts and say list. It was run host prime, wasn't it? Yeah. Run host prime. Kinda. So run host prime, but it's going to need an argument, and that argument is a list containing list. Okay, and that unfortunately spits to standard out. It doesn't actually return the things, it prints them out. So testing that's going to be quite hard. So if we got something inside here which doesn't print them out, I don't think we do. We do just have a look at list hosts, but all I'll be doing is, and that's annoying. So all this is going to do is call the mock storage, and that's not what we want to do. So is there a thing I can do with hspec to test stood out? So hspec test stood out. Don't want pending, don't want focus, don't want hooks, don't want running a spec. Where are the matchers? So the thing I'm using is should be. What was an expectations? Okay, so should not be, should satisfy, should not return. I don't think we can. So we could change it to be either writer rather than IO, or because it's monad IO, could we fake IO? Right, because the type of env is appenv, which is, it's not going to tell me what that is, but it's up here. App, sorry, is, oh no, that's not what constraint is. Constraints at their end. So in run hosts, it's monad IOM. Oh, the trouble is env though. It's going to get really complicated. I was thinking, instead of run reader t, I could then run my own special monad, which has got reader only. See, append. This is coming in, so append is just environment. Right, so that's the environment. Then we call run reader t directly. How do we call it from main? Same thing. And then in here, we say it has to be whatever this thing is. So this is reader t, which is because of run reader t, and append s, which is the append with some storage, which is our mock storage, and then m, this monad, which I said must implement monad IO. So if I wrote something that implemented monad IO and ran the spec under it, would that work? I get the feeling it wouldn't work. Or I'd get very lost very quickly. hspec test IO. It must be a way of doing this, but I don't know. I don't know how to do it. Segmentations. No, I'm sure there is a way of doing it, but I don't know how to find that thing. Oh. Should return. Okay. I could try that. Okay, so I don't want to evaluate this. I want to say let h equal, and this can evaluate for me. Okay, and then we should get a string, which is Bob, and then Betty on a new line. I don't think this is going to work. So we do. I'd like to see an example of this because I'd like to see what type launch missiles has. I'm guessing it's IO of either string or something, but I don't know. What is this? No. Okay. The problem is this returned unit. Right. So it's not intercepting IO. It's just running under IO and then checking the return, and that's not what I want either. Test Strillin. That's kind of the other way around. This is not what I wanted. I want the other way around. I'm not testing input when I test output. I mean, it feels like the correct answer is that I separate out the pure code from printing the output. I don't think this is going to help me. No. Rather than trying to test this impure code. Trouble is that the pure code is actually very boring here. And it's also not exposed, although I could move this into like an internal. So what's this going to do? It's going to get storage, and then it's going to get the host back and then print them out. So I wonder if this could become. See, this isn't pure either, but at least it doesn't rely on printing stuff out. Have I got any other tests? No, I got host and episode spec. And I haven't done any of this yet. Okay, maybe my spec is pointless, right? So host can be listed is not testing anything useful because we're just getting whatever storage gave to us. There is no logic to be tested. But there is a little bit of logic in adding participants. No, there's not, because it relies on the underlying storage to throw this exception. So that's not good either. There's basically no logic in the thing that it's testing. I've pushed it all down to the underlying layer. It's really just running a thing. And that thing is whatever's in the storage layer. And then printing the result. And printing out the result is the thing that I can't test very easily. So I really need to find something that's got some logic, and then I can separate the logic out and check that. But there was a thing when maybe I haven't written this code yet, but when they said they're promoting someone to be a host, but I actually think that worked by deleting and then re-adding them. Yeah, you can't add a host if they're already in the cast. It doesn't auto promote them. Okay, that's not great. I mean, maybe you could write that because that's a little bit interesting. So I'll add a new command. So promote moves a cast member from participant to host. So let's add promote. Okay, we need a little bit more storage here, but I'm going to promote Hetty. And because this is taking args list, it'll be like that. So mock load participants, and it's going to be back in list participants. Participant. So mock load participants is going to be participant, and then we'll have Hetty and Harry as our two participants. So somewhere I'm importing participant. Where here? Put in the constructor as well. Okay, so I can now use this when we're list participants. It's going to be pure of mock load participants. Okay, so we have participants and we have hosts. Right. If we go back to my other test, I did this thing where I use a T-var somewhere. Okay, so the storage itself contains commands. And then I instantiate the storage with an empty list. Then what's it doing? Oh, okay, so we're checking that it calls add and then truncate, or truncate and add actually it would be on the underlying storage, right? But I can do something similar, right? So I can say that if I promote someone, we should be calling delete or remove participant, and then we should be calling add host. Okay, that's a test I can write. And it's going to be this type. Okay. So let's import T-var. Which one did I import before? JC-conc. I will import text. Okay, so now we have get rid of that. Okay, so now we can say, I'll grab this line of code as well. So we'll say this, inside our test. And we will create our S. Oh, we can just do it here, can we? Oh no, we want to refer to S later, so that's why we'll do it here. Okay. And then we run it. Then we get that back. So we're gonna ignore the result because it's gonna be a unit. We don't really care what it is. So actual command is going to be this, which I will import. Okay, and then we'll say actual commands should be, and it's going to be a list of commands, and this is going to be remove participant hetty, and then it's going to be in the head of the list. The list will be reversed because it's easier to push onto the head than add to the tail. But it should be add host hetty. Okay, and then we should start storing these things. So it was store command. You give it storage and the command. So let me just pull this in. We need to pull in atomically. We need to pull in read tvar and write tvar. Okay, so we're not going to use topics, but for participants, right, we say given some storage and some participant P, it's going to be store command where we give it this S and then some text, and the text is going to be remove participant and P t.pack P. No, it's p.getParticipant. That's right. So we're stripping out the type. Okay, and then add host. It's going to be very similar. So we're called store commands, and we will call this add host. Okay, that returns unit, so we're just going to say, we'll ignore that, and we will say pure write of unit. And this is going to be an H, not a P, because it's a host, and it's going to be H.getHost. Okay, so in theory, if I run this now, promote won't work because I haven't written it, but it would, if it did call these commands, they should be captured, and I should be able to say this is how you use storage. Not super useful, but I guess I'm more interested in how to write a test rather than writing a useful test at this point. Okay, so my episode spec is completely broken. Do all of this stuff. And we just need an empty do, I think. So we can say true should be true. Just to make it compile. Episode spec. Define will not use mock storage. Okay. Effectively deleted the whole file. Wow. would have been quicker to delete the file, wouldn't it? Let's move to trash. Maybe go back to compile file. And delete abstract from the test. Oh, got reformatted. Okay. So back to here. Let's recompile it. Okay. On exception error call. And I think that's because in here, I probably just throw an error, unexpected command. So if you say run host prime promote name is run host prime run promote prime. What am I doing? Run promote prime. Oh, this is not run host, is it? It's actually, okay, so it's going to be host promote. Doesn't make sense. It should be a participant promote. So it'll be, yeah, I would say participants promote Hetty in this case. So run promote participant and then pass in the name. Okay, I can get it to fill it in for me, but I think it makes a bit of a mess of this. Because it's saying suggested fix. Okay, and then we don't have constraints either, but that's okay. So we have a name. Okay, and we can say let, oh, it's going to be the same as remove, first of all. So we can just say run remove participant name, and that's going to need cast storage OS and probably monad IO of M, monad IO of M. Okay, so we remove them and then we say run add host prime of name. All right, why is that not happy? Run. It's called run add hosts for some reason. But it should really just be run add host. There we go. Where's my promote? Okay, here we go. Let me say that. So we remove participant and we add the host. That's what we're going to try and do. So back to the test. It's called host spec, but it's actually promoting a participant. So we're not going to run hosts, but we're going to say run participants. That will import. Okay, that's what should happen. There we go. So it removes participant and then adds them as a host. So yeah, back here. I could demote a host, so moving back to participant. So it moves a cast member from host to participant. Very similar thing. So in this case, we are demoting a host. And it doesn't really matter because we're not really moving people around, but we're going to demote Bob, who's at this point a host. And then it should be remove host Bob and then add participant. Participant Bob. Okay. So I run that, we'll get an error. Unexpected command demote Bob. So back to commands, and in our run hosts, we will have run hosts demote name. I'm going to hardcode Bob. Run demote host prime name. And that. Okay, so given some name, we want to say run remove host name and then run add participant name. And this is going to be cast storage S and monolio of M. Okay. Okay, it's a test fault because I didn't fill these things in. So remove host, give him some storage and a host is going to be store command S, and it's going to be remove host and h dot get host. And add participant is going to be this. Again. So that was get host. Here we did fill in S and P. So this is going to be p.getParticipant. Okay. So now when we call these commands, they should be stored. So demote should have got remove host and add participant, but got remove host and add host. Because again in the spec, I didn't fix that text. And there we go, it works. Okay, cool. So not the best tests, but it does at least start to move over to using the new type classes. We do use this in the test now. We actually don't use the listing. Okay, I can maybe find a nicer way of expressing this, but the idea is that we just have some mock storage, and then when you call it, it just stores the name of that command. And then later on, when we have something even slightly complicated, we have to do two things together. We're just saying promote is made up of these things. Really not great tests. But it does at least show that I can swap the storage out for some in-memory storage if I need to. So that was cool. This is a thing. I might try and use that thing. I don't know. Being able to refer to storage once rather than multiple different storage type classes might be useful, but I'm not convinced. And then finally, I didn't find a way yet to be able to swap the storage out. So I'll have a think about that for next week. Maybe look up a little bit on how to do it. But I should be able to say, if you pass in a particular command and argument, create a particular type of storage and then use that later on when we're calling this thing, make up env. But yeah, I don't really know how to do that. Okay, cool. Anyway, I think I'll leave it there for tonight. A little bit slow, sorry, I'm still getting back into streaming and programming. But hopefully it was at least slightly enjoyable. And then hopefully see you again next week. Thank you for watching along. Goodbye.